In the fast-paced world of technology, the amount of electronic waste we produce is staggering. In fact, did you know that in just 1 year, we generate over 50 million tons of electronic waste across the globe? This growing pile isn't just a statistic, it's a looming crisis threatening our environment. As our cities expand and embrace smarter technologies, the need for sustainable solutions becomes more urgent than ever. But what if our electronics could decompose as easily as everyday organic waste? Enter the game-changing realm of biodegradable electronics, a field poised to transform our flashy urban landscapes into eco-friendly havens. Imagine a future where our devices not only enhance our lives but also leave no trace behind. Yet, how exactly do these marvels work? What challenges do we face in making them a staple of our smart cities? In this video, we'll delve into the innovative minds driving these technologies, explore real-world applications, and ponder their potential to reshape our urban futures. So, stick around as we uncover the fascinating technology behind biodegradable electronics, setting the stage for a sustainable revolution. To truly grasp the revolutionary concept of biodegradable electronics, let's start by understanding what sets them apart from the conventional gadgets we've grown accustomed to. Unlike traditional electronics composed primarily of long-lasting, non-degradable materials like silicone and plastics, biodegradable electronics are designed with nature in mind. Their defining feature is their ability to break down harmlessly into the environment after fulfilling their purpose. This eco-friendly characteristic hinges on the use of innovative materials such as organic polymers and transient electronics. Organic polymers are long chains of carbon-based molecules that can decompose naturally. Think of them like the leaves on a tree. Just as leaves grow, serve their purpose of photosynthesis, and eventually fall to the ground, enriching the soil as they decay. These organic polymers exist to perform specific functions before returning safely to the earth. This natural life cycle not only aids in reducing waste but also prevents the accumulation of toxic substances in our environment. Then there's the fascinating world of transient electronics. These devices are engineered to dissolve in the presence of moisture after a set period. Imagine a sugar cube dissolving in your morning coffee. Transient electronics operate on a similar principle, disappearing once they've achieved their purpose. They are particularly appealing for medical applications, such as temporary implants that don't require surgical removal, thereby minimizing medical waste. The potential of these materials to curb environmental pollution is immense. According to experts in the field, the transition to biodegradable electronics means we could significantly reduce the burden of e-waste, which is projected to double in the next 3 decades if current trends continue. Dr. John Rogers, a pioneer in this domain, highlights that these electronics can be inexpensive to produce and tailored for a vast array of applications, from disposable medical devices to single-use sensors in environmental monitoring. However, this promising technology does not come without its challenges. Biodegradable electronics must maintain functionality while being biodegradable, two qualities that don't always align naturally. Researchers are relentlessly working to find the perfect balance of performance and sustainability. Ensuring these materials are as effective as their non-degradable counterparts, yet safe for the environment, requires significant innovation and investment. Now, let's explore how these advanced materials support smart city infrastructures. As cities evolve toward smarter, more interconnected environments, the integration of biodegradable electronics can play a vital role. Imagine sensors that monitor air quality, traffic patterns, or even building safety that degrade without a trace once their job is done. This would not only maintain city functionality, but also enhance its sustainability, helping to achieve goals of reducing the carbon footprint and supporting a circular economy. As we further investigate these materials and their applications, it becomes clear that biodegradable electronics hold the key to a greener future. They present an inspiring vision for cities that are not only intelligent but sustainably so, paving the way for the next generation of urban living. So, as we step deeper into this world of possibilities, let's consider how this innovation aligns with the ongoing development of our cities, setting new standards for environmentally conscious technology. As we visualize the cities of tomorrow, an intricate tapestry woven with technology and sustainability, biodegradable electronics emerge as a crucial thread. These innovative devices are not just about reducing waste, they offer a new dimension to urban living by seamlessly integrating into smart city infrastructures. Let's delve into the transformative role these eco-friendly technologies can play in enhancing the quality of life and sustainability within our urban environments. Imagine walking through a park where the very air you breathe is constantly monitored by tiny, biodegradable sensors. These sensors, part of an interconnected network of Internet of Things devices, can track air quality with precision, providing real-time data that city planners and health officials can use to mitigate pollution levels. Unlike traditional sensors, which often contribute to electronic waste once their lifespan ends, these biodegradable alternatives would simply dissolve harmlessly, leaving no environmental footprint. This vision isn't confined to monitoring air quality alone. Biodegradable electronics can revolutionize waste management systems in smart cities, turning them into efficient, self-regulating ecosystems. Picture intelligent waste bins equipped with transient sensors that can alert sanitation workers when they are full or even detect the type of waste they contain, optimizing the recycling process. After their use, these sensors biodegrade, ensuring no residual waste clutters the landscape. Experts like Dr. Maria Gomez, a leading researcher in sustainable technology, argue that integrating biodegradable electronics into smart city infrastructures could drastically reduce energy consumption. Traditional electronics require significant energy for manufacturing and waste disposal processes, whereas biodegradable alternatives are designed to optimize energy usage throughout their life cycle. It's not just about the devices themselves, Dr. Gomez explains. It's about creating a harmonious system where technology supports and improves the urban ecosystem without depleting its resources. The implications of these advancements extend beyond mere convenience. By adopting biodegradable electronics, cities can move towards a circular economy model where resource inputs and waste outputs are minimized. This shift not only addresses environmental concerns such as reducing landfills and emissions, but also sets a precedent for other sectors to follow. Yet, the journey toward such smart, sustainable cities requires significant infrastructural shifts. Existing systems need to adapt to accommodate these new technologies. For instance, there needs to be a robust framework for the deployment and integration of biodegradable devices, as well as policies that incentivize their adoption. This transition will demand collaboration between government bodies, tech companies, and urban planners, each playing a vital role in reshaping the urban landscape. As we consider these possibilities, it's also worth reflecting on the broader environmental benefits. The proliferation of biodegradable electronics can help reduce the overall carbon footprint of cities, contribute to cleaner urban environments, and promote a healthier planet. By making such technologies a focal point in smart city development, we can pave the way for a future where technological advancement goes hand in hand with ecological preservation. So, as we look to the future of our cities, let's consider how these pioneering technologies could redefine the urban experience. How can we, as individuals and communities, support and advocate for these changes? And more importantly, how can we ensure that our pursuit of smarter cities does not compromise the health of our planet? These are questions that we must address as we stand on the brink of a new era in urban development, one where biodegradable electronics play a pivotal role in shaping a sustainable tomorrow. When we talk about the environmental benefits of biodegradable electronics, we open the door to a cleaner, greener future. These innovative devices hold the promise to dramatically reduce the mountains of electronic waste we see today. By integrating biodegradable electronics into urban settings, we can minimize the harmful impact of e-waste and promote sustainability far beyond current measures. Consider this: electronic waste is one of the fastest-growing waste streams worldwide, with millions of tons discarded annually. Traditional electronic components like plastic and heavy metals can linger in the environment for hundreds of years, leaching toxins and taking up valuable landfill space. Adopting biodegradable electronics, however, allows us to mitigate this issue significantly. These devices are designed to decompose into non-toxic components naturally, effectively closing the loop in their lifecycle management and ensuring they leave no lasting residue. Environmentalists are particularly optimistic about this shift. Jane Peterson, a renowned environmental advocate, emphasizes the potential impact. The transition to biodegradable electronics offers immense promise not just for reducing waste, but for fundamentally altering how we interact with the planet. It's about creating a sustainable cycle where technology doesn't just serve us, but also respects the natural world. This holistic approach helps cities lower their carbon footprints, contributing to broader global efforts to combat climate change. Imagine walking through a city where the very infrastructure naturally supports and enhances the environment. Sidewalk sensors monitor foot traffic and street lights that respond to ambient light levels, all while being made from materials that safely decompose over time. This vision of cleaner cities is not just a distant dream but an imminent reality, thanks to biodegradable technologies. With fewer non-degradable electronics ending up in landfills, cities can reduce their waste management burdens and reclaim valuable land for green spaces, community development, and agriculture. Moreover, these eco-friendly technologies enable a significant reduction in the overall pollution associated with electronic manufacturing and disposal. The production of traditional electronics often involves energy-intensive processes that contribute to greenhouse gas emissions. In contrast, biodegradable electronics require less energy to produce and dispose of, aligning with goals for reduced emissions and cleaner production methods. This shift not only benefits the environment but also sets a new industry standard for sustainable manufacturing. The environmental advantages naturally lead us to consider the economic impacts as well. As cities adopt biodegradable electronics, they can expect to see reduced costs associated with waste disposal and environmental cleanup. By investing in sustainable technology, cities can alleviate some of the financial pressures associated with managing electronic waste, allowing funds to be redirected toward other critical urban development projects. Additionally, as the demand for biodegradable materials grows, new markets will emerge, spurring innovation and job creation within the green tech sector. The potential for biodegradable electronics to reshape our urban landscape is enormous. By aligning economic incentives with environmental preservation, cities can not only become smarter but also more sustainable. As we continue to explore the integration of these technologies, it's crucial that we remain proactive in supporting their development and implementation. Ultimately, by championing the use of biodegradable electronics, we are not only making strides towards smarter cities, but also fostering a healthier planet for future generations. The transition may require collective effort and commitment, but the rewards of cleaner cities and a reduced ecological footprint make it a journey worth pursuing. Thus, as we move forward, let us embrace these innovative solutions, driving the change towards an eco-friendly urban future. Transitioning to biodegradable electronics in smart cities isn't just a story of ecological triumph, it's an economic narrative ripe with potential. By examining the financial aspects, we can appreciate how these innovations sow the seeds for economic rejuvenation. The implementation of biodegradable electronics is marked by several financial dynamics, from upfront costs to significant long-term savings and market shifts that could redefine global economic landscapes. To begin with, the initial costs of adopting biodegradable electronics might seem daunting. These include research and development to refine materials and manufacturing processes, and the infrastructure needed to support the transition from traditional to biodegradable technologies. However, as with many technological innovations, these initial costs are an investment rather than a burden. Over time, as production scales and methods become more efficient, the costs are expected to decrease, making these technologies more accessible. In terms of cost savings, one of the most significant advantages lies in reducing waste management expenditures. Traditional electronic waste requires complex and costly disposal and recycling processes to mitigate environmental harm. By replacing these with biodegradable options, cities can drastically cut down on waste disposal costs. This is particularly beneficial for municipalities that struggle with limited waste management budgets and are constantly seeking more efficient ways to handle urban waste. An encouraging real-world example can be found in the city of Eindhoven in the Netherlands, which has been a pioneer in integrating biodegradable electronics into its urban fabric. Eindhoven's city planners have implemented sensors that decompose naturally, reducing the need for electronic waste disposal. The city reported a 20% decrease in waste management costs within the first few years of the project's inception. This reduction has allowed for reallocation of funds towards other critical areas, such as public transportation enhancements and renewable energy projects. Additionally, the shift to biodegradable electronics paves the way for long-term economic benefits. Economists suggest that as demand for green technology grows, so too will the creation of green jobs. These are positions related to the research, development, and manufacturing of sustainable technologies. This sector not only promises new employment opportunities, but also supports a more resilient economy by reducing dependency on finite resources and fossil fuels. Market dynamics are set to change as well. As biodegradable electronics become more mainstream, we can expect to see a shift towards circular economy models where products are designed for reuse, repair, and recycling. Companies that adopt this model stand to benefit from cost efficiencies and can position themselves as leaders in sustainability, potentially capturing a larger market share as consumer preferences tilt towards eco-conscious products. However, the transition comes with challenges. The global market must adapt to the new demands of sustainable production, requiring multinational collaboration and policy support. There may be resistance from industries heavily invested in traditional electronics, requiring thoughtful regulation and incentives to encourage adoption. Despite these challenges, the overall economic outlook for cities adopting biodegradable electronics remains promising. By investing in these technologies, cities can not only reduce their environmental footprint, but also position themselves as economic trailblazers in the green tech revolution. As more cities follow Eindhoven's lead, the momentum will likely drive global market trends towards a sustainable and economically viable future. This evolution underscores a critical point. The integration of biodegradable electronics is not just an ecological imperative, it is an investment in a prosperous and sustainable economic future. As cities worldwide continue to explore and implement these sustainable technologies, they will lay the groundwork for a smarter, greener, and more economically secure tomorrow. The journey may be complex, but the potential rewards make it an essential endeavor for smart cities striving for sustainability and economic resilience. While the promise of biodegradable electronics is alluring, their development and deployment come with a set of formidable challenges. Addressing these issues is crucial for realizing their full potential in transforming smart cities into sustainable marvels. Let's delve into some of the primary hurdles, starting with technological limitations, then moving to life cycle management, and finally tackling regulatory concerns. At the heart of these challenges is the technological limitation of these devices. Creating electronics that can perform complex tasks while remaining biodegradable is no small feat. The materials used must strike a delicate balance between durability during use and rapid decomposition afterward. Current research is heavily focused on enhancing the performance characteristics of biodegradable materials. For instance, scientists are exploring the use of bio-derived polymers and proteins that can provide stability without sacrificing eco-friendliness. Despite these efforts, achieving the same level of performance as conventional electronics remains a significant obstacle. Industry leaders like Dr. Emily Wu, the chief scientist at Green Tech Innovations, acknowledge that while strides are being made, there is still a long way to go. We need to push boundaries to develop materials that are not only biodegradable but also robust and versatile enough for varied applications, she asserts. Lifecycle management presents another layer of complexity. Unlike traditional electronics, which are designed for longevity, biodegradable devices are intentionally transient. This characteristic demands a new approach to design and use where the entire life cycle, from creation to degradation, is meticulously mapped out. Engineers and designers must consider how these devices will integrate into existing systems and what happens once their usable life ends. This requires developing new recycling and disposal methods that align with their biodegradable nature, ensuring they decompose without harming the environment. Regulatory hurdles also pose a significant challenge. Currently, the regulatory framework for biodegradable electronics is not as mature as that for traditional electronics. Standards and guidelines are needed to ensure the safety, efficacy, and environmental impact of these products. Policymakers are beginning to take notice, with some governments initiating discussions on creating such frameworks. For example, the European Union has begun drafting regulations to guide the production and use of biodegradable electronics, setting a precedent for other regions to follow. To overcome these barriers, industry leaders advocate for increased collaboration between academia, industry, and government. Joint initiatives can accelerate research and development, helping to create solutions that balance technological feasibility with environmental sustainability. Dr. Wu emphasizes the need for interdisciplinary efforts, stating, "Collaboration is key. By bringing together engineers, scientists, policymakers, and industry experts, we can solve these complex challenges more effectively." Current research efforts are concentrated on scaling these technologies for broader impact. Laboratories worldwide are experimenting with new biodegradable materials, such as cellulose-based substrates and silk protein blends, which promise improved performance without compromising eco-friendliness. Scaling these innovations requires not only technical advancements, but also significant investment in infrastructure to support mass production. These challenges play a pivotal role in shaping policy and innovation within the context of smart cities. As cities strive to become more sustainable, integrating biodegradable electronics could serve as a catalyst for innovation, reshaping how urban environments are planned and developed. Policymakers must consider these technologies in their long-term strategies, crafting policies that support research and incentivize the adoption of eco-friendly alternatives. Looking forward, as the dialogue between innovators and policymakers deepens, the path will likely clear for more breakthroughs in the field. Such advancements could drive the next wave of smart city solutions, blending technology seamlessly with ecological intelligence. The ongoing research and collaborative efforts foreshadow a future where biodegradable electronics are not just an alternative but a cornerstone of sustainable urban living, heralding a new era of eco-conscious technological evolution. Let's dive into the thrilling arena of recent breakthroughs in biodegradable electronic technologies. These innovations promise to redefine how we envision and utilize electronics in our everyday lives, driving us closer to a future where technology and nature coexist harmoniously. One of the most exciting advancements comes from researchers at Stanford University, who have developed a groundbreaking biodegradable battery. This battery uses a combination of polymers and cellulose to create a fully functional power source that decomposes into non-toxic byproducts. Imagine powering your wearable tech or temporary medical devices with a battery that disintegrates safely into the environment after use. This innovation not only paves the way for more sustainable electronics, but also addresses the pervasive issue of toxic waste from conventional battery disposal. Moving to Europe, scientists at the University of Cambridge have unveiled a revolutionary biodegradable circuit board. Traditional circuit boards are notorious for their environmental impact due to their complex mix of non-degradable materials. The Cambridge team's approach involves using a base of cellulose fiber combined with conductive inks derived from graphene. Graphene, a single layer of carbon atoms renowned for its strength and conductivity, enables these boards to perform with remarkable efficiency while remaining eco-friendly. These advancements represent significant strides in making entire electronic devices biodegradable, not just their components. In the realm of wearable technology, researchers at the Massachusetts Institute of Technology are pioneering textiles embedded with transient sensors. These sensors are woven directly into fabric using silk-based threads, known for their biodegradability and strength. This innovation opens up possibilities for smart clothing that can monitor health metrics and environmental conditions, all while being gentle on the planet after their functional life. These prototypes and research initiatives are not just about creating new devices. They are about reimagining the manufacturing processes themselves to align with circular economy principles. For instance, 3D printing techniques are being adapted to use biodegradable materials, reducing waste and energy consumption in electronics production. This process allows for more customization in device manufacturing, tailoring electronics to specific needs and reducing the surplus often seen in mass production. Visuals of experimental models from these research labs showcase a fascinating blend of creativity and cutting-edge technology. Imagine a biodegradable smartwatch, its sleek design indistinguishable from its traditional counterparts, yet wholly sustainable in its life cycle. Or consider a smart sensor embedded in urban infrastructure, monitoring conditions and dissolving harmlessly after its job is done. These prototypes hint at the immense potential for smart cities to be equipped with intelligent, eco-friendly tech solutions. As these technological breakthroughs take center stage, they naturally lead us to ponder future trends in smart cities. The integration of biodegradable electronics suggests a shift toward urban environments that prioritize sustainability without sacrificing innovation. This alignment with eco-friendly technologies could redefine urban planning, supporting cities that are not only smarter but also more attuned to the needs of their inhabitants and the planet. These innovations indicate a promising trajectory towards a future where biodegradable electronics become mainstream. As research and development continue to progress, we might soon see these technologies transition from labs to everyday life, enhancing our surroundings while safeguarding the environment. The exciting interplay between innovation and sustainability invites us to look forward to a time when our cities are as intelligent as they are green, heralding a new era of eco-conscious urban living. As we gaze into the future of urban environments, the role of biodegradable electronics in smart cities presents a landscape rich with potential, not just for technological advancement but for redefining what it means to live sustainably. The next frontier in urban development is set to be marked by increased integration of eco-friendly technologies, and biodegradable electronics stand at the forefront, heralding a shift towards cities that are as conscious of their environmental footprint as they are connected and efficient. One anticipated trend is the seamless blending of biodegradable systems into everyday urban infrastructure. Picture cities where entire networks, from traffic management to energy grids, are powered by devices that perform optimally and then fade away without a trace once their life cycle completes. This could mean streetlights equipped with sensors that monitor environmental conditions, dissolving harmlessly once they need replacement. Such systems eliminate the need for extensive waste management and reduce the environmental toll typically associated with traditional electronic systems. Futurists predict that these advancements will encourage urban planners and policymakers to design cities with sustainability at their core. The integration of biodegradable electronics can spur the creation of circular cities, urban areas where resources are reused and recycled continuously, minimizing waste while maximizing efficiency. Imagine a city thriving entirely on renewable energy, where every electronic component is not just smart but also aligned with nature's life cycle. Water systems, transport networks, and even building materials could be interwoven with smart sensors that not only optimize operations but biodegrade once their job is done, leaving behind no detrimental impact. Experts also foresee a growing movement towards decentralized energy systems powered by renewable sources like solar and wind. In this setup, biodegradable electronics can play a crucial role by managing and optimizing the flow of energy within microgrids. These localized networks could ensure that energy resources are used most efficiently, reducing reliance on fossil fuels and enhancing resilience against broader grid failures. The potential for biodegradable electronics to catalyze these changes is immense, but the global implications require a concerted international effort. Countries will need to collaborate to formulate policies that promote green technologies and support research and development in this arena. Sharing knowledge and resources can accelerate the adoption of biodegradable electronics, allowing cities worldwide to benefit from sustainable innovations. The role of international organizations and cross-border partnerships will be crucial. Entities like the United Nations and the World Economic Forum can facilitate dialogue and cooperation between nations, ensuring that technological advancements are shared equitably and implemented in ways that respect both economic and environmental imperatives. As we envisage these smart cities of the future, it's essential to encourage viewers to imagine themselves in these environments, living in a world where urban life doesn't come at the expense of the planet. It's a world where technology exists in harmony with nature, where our daily interactions with electronic devices contribute positively to the ecological balance. This vision of smart cities shaped by biodegradable electronics is not the stuff of distant dreams but a blueprint for what can soon become reality. The path forward involves embracing these technologies, fostering innovation, and committing to sustainable development. Just as cities of the past were built on the innovations of their time, the cities of the future will be defined by how effectively they incorporate green technologies, ensuring a thriving, sustainable existence for generations to come. By envisioning this future, we set the stage for meaningful change, moving towards a world where technology enhances our lives without compromising the health of our planet. The widespread adoption of biodegradable electronics in urban centers holds the promise of profound global impacts that extend far beyond environmental benefits. As cities around the world embrace these technologies, we are likely to witness a significant shift in how nations collaborate and innovate together towards a more sustainable future. This movement is not only about reducing electronic waste, but also about redefining global partnerships and encouraging a united front in the fight against climate change. First and foremost, the adoption of biodegradable electronics on a global scale could dramatically reduce the environmental footprint associated with traditional electronic waste, which currently accounts for a significant portion of pollution worldwide. By transitioning to eco-friendly alternatives, countries can work together to meet international climate goals, such as those outlined in the Paris Agreement, reducing carbon emissions and alleviating the strain on natural resources. International efforts and collaborations are crucial in fostering sustainable smart city development. The Global Organization for Sustainability in Technology has emphasized the need for a unified approach in a recent report. According to the report, international collaboration is imperative to harness the full potential of biodegradable electronics, ensuring that technological advancements benefit all nations, particularly those vulnerable to climate change. One such collaboration is the recent Sustainable Cities Summit held in Copenhagen. This event brought together leaders from over 50 countries, including policymakers, scientists, and industry experts, to discuss and strategize the integration of biodegradable electronics into urban planning. The summit highlighted successful case studies, such as Singapore's initiative to deploy electronic waste reduction strategies and Denmark's advancements in biodegradable materials research. These examples serve as blueprints for other nations, showcasing how collaborative efforts can drive tangible results. Global organizations like the United Nations Environment Programme have also played a pivotal role in facilitating these dialogues. At the summit, the UNEP released a statement urging countries to prioritize investments in green technology and foster partnerships that bridge the gap between innovation and implementation. Their advocacy underlines the importance of a cooperative approach where shared knowledge and resources can accelerate the transition to sustainable urban environments. The potential economic benefits of such collaborations are substantial. By pooling resources and expertise, countries can stimulate new markets for green technologies, promote job creation in the sustainable tech sector, and enhance their competitive edge in the global economy. This not only contributes to environmental sustainability, but also drives economic growth, presenting a win-win scenario for all involved. In light of these discussions, it's essential to highlight the role of individual contributions in this global movement. While international efforts are crucial, the success of biodegradable electronics relies heavily on localized actions and personal engagements. Cities and communities must take initiative in adopting and promoting these technologies, while individuals can contribute by supporting sustainable practices and advocating for eco-friendly policies. As we reflect on the potential of biodegradable electronics and the global momentum building around them, it becomes clear that the path forward requires a collective commitment. We are at a pivotal moment where technological innovation can lead to meaningful change, but only if we come together as a global community. Policymakers, businesses, researchers, and citizens alike must recognize the opportunities afforded by biodegradable electronics and take action to make their integration a reality. In closing, let us remember that the journey towards sustainable smart cities is not just a technological endeavor but a collaborative mission. By harnessing the power of international partnerships and individual actions, we can pave the way for a future where cities thrive in harmony with the planet, setting a standard for innovation and environmental stewardship for generations to come. To better understand the journey towards integrating biodegradable electronics into urban landscapes, we must first explore the practical steps cities are taking to implement these groundbreaking technologies. This process involves pilot programs, strategic partnerships, and a keen focus on innovative strategies that allow for smooth integration within existing infrastructures. Start by examining pilot programs as a crucial first step. These programs serve as experimental platforms where cities can test and refine biodegradable technologies on a smaller scale before full-scale implementation. For example, the city of Lyon in France has embarked on an ambitious pilot project to incorporate biodegradable sensors in public transport systems. These sensors monitor environmental conditions such as air quality and temperature within buses and trams. By starting with a pilot, Lyon can assess the effectiveness and resilience of the technology in real-life conditions, gather data, and make necessary adjustments before broader rollout. Strategic partnerships between public entities and private technology firms are also vital in advancing biodegradable electronic solutions. For instance, in Amsterdam, a collaboration between the city government and a tech startup resulted in the development of biodegradable lighting systems for public parks. These lights adjust according to natural light levels and decompose entirely after their life cycle, reducing maintenance costs and environmental impact. This partnership illustrates how pooling expertise and resources can create tailored solutions that meet specific urban needs. To seamlessly integrate these technologies into existing city infrastructure, urban planners and policymakers need to adopt thoughtful strategies. One effective approach is retrofitting existing systems to accommodate new technologies without needing complete overhauls. In Seoul, South Korea, city planners have successfully integrated biodegradable elements into their current waste management system. By embedding transient sensors in waste bins across the city, they optimize routes for garbage collection services, ensuring bins are only emptied when necessary. This method not only utilizes biodegradable technology but also enhances the efficiency of existing systems. To ensure successful adoption, cities must also consider policy frameworks that support the transition. This includes incentives for businesses investing in green technology and creating regulations that prioritize sustainable materials. In San Francisco, the City Council introduced tax breaks for companies that integrate biodegradable components into their products or services. This policy encourages innovation and aligns corporate goals with the city's sustainability objectives. Success stories from cities that have initiated eco-friendly practices serve as blueprints for others looking to follow suit. The experience of these cities underscores the importance of a staged approach, starting with pilot programs, fostering partnerships, and implementing supportive policies. Each step, when strategically executed, paves the way for a more sustainable urban environment. As we consider these transformative practices, it's crucial to recognize the role of education and public awareness in the broader adoption of biodegradable technologies. The success of these initiatives depends not only on the technology itself, but also on fostering a culture that values sustainability and innovation. Educational campaigns can help residents understand the benefits of biodegradable electronics and how these changes contribute to a healthier environment. Engaging community members in discussions about sustainability and innovation can inspire them to support and participate in the city's green initiatives. Cities that successfully integrate biodegradable electronics offer valuable insights for those exploring similar paths. As urban centers worldwide continue to grow and evolve, the lessons learned from these pioneers can guide the way toward a future where technology and ecological responsibility coexist seamlessly. By taking these practical steps, cities can position themselves at the forefront of sustainable urban development, setting an example for communities and generations to come. To fully realize the potential of biodegradable electronics in revolutionizing our cities, education and awareness must take center stage. Fostering a culture of sustainability hinges on informed citizens who understand not only the benefits of these technologies, but also their broader impact on the environment and quality of life. By prioritizing educational initiatives, cities can cultivate a generation that values and actively participates in sustainable practices. Education begins at the grassroots level, with programs designed to reach both individuals and industries. Schools and universities play an indispensable role in this effort by incorporating sustainability into their curricula. Courses that focus on environmental science, technology, and innovation provide students with a comprehensive understanding of the challenges and opportunities in the field of biodegradable electronics. For instance, the Green Future Initiative at the University of California has developed hands-on modules where students learn to design and prototype biodegradable devices, instilling an appreciation for sustainability from an early age. Beyond formal education, public awareness campaigns are essential in shaping community behavior and attitudes towards sustainable technology. Take the Ecotech Festival in Melbourne, for example, which is an annual event that showcases the latest in green technology, including biodegradable electronics. The festival invites industry experts, educators, and the general public to engage in workshops, demonstrations, and discussions, creating a vibrant forum for learning and innovation. Events like these not only highlight the benefits of adopting sustainable practices, but also demonstrate how individuals can integrate these technologies into their everyday lives. Industry, too, benefits from targeted educational initiatives. Workshops and seminars tailored to businesses can spur the adoption of sustainable technologies by demystifying the production and implementation processes associated with biodegradable electronics. The Sustainable Business Network in New Zealand has successfully conducted a series of workshops that educate companies about the economic and ecological advantages of green technology, encouraging them to incorporate biodegradable solutions in their operations. Thoughts from educators and community leaders further emphasize the importance of knowledge dissemination in driving change. Dr. Laura Chang, a leading environmental educator, underscores the necessity of an informed public. Education is the cornerstone of sustainable development. By equipping people with the knowledge of biodegradable technologies, we empower them to make choices that reduce their environmental footprint. Her sentiment echoes the views of community leaders like Erin Thompson, the director of Eco-City Alliance. Thompson believes that change begins with awareness. We can't expect communities to embrace sustainable practices without understanding their significance. Awareness campaigns are crucial in translating knowledge into action. One successful example of a public awareness campaign is the Green is the New Black initiative in Toronto. This campaign utilized social media, workshops, and citywide advertisements to educate the public on the importance of sustainability and how biodegradable electronics can play a pivotal role. By making sustainability fashionable and accessible, the campaign effectively engaged a broad audience and encouraged the adoption of eco-friendly habits. Through these efforts, education and awareness become a powerful catalyst for change, inspiring communities to embrace sustainable futures actively. By framing the narrative around knowledge and participation, cities can foster an enduring culture of sustainability that supports the ongoing development of biodegradable technologies. This informed engagement is not just a pillar of smart city evolution, but a crucial step towards realizing a world where technological advancement complements environmental stewardship. In conclusion, as we strive to create cities that harmonize with nature, education, and awareness, are the linchpins that hold the promise of a sustainable future. By investing in knowledge and understanding, we equip individuals and industries to become advocates for change, paving the way for a greener, brighter tomorrow. As we look forward to this future, let's commit to learning, sharing, and growing together, ensuring that the innovations of today become the sustainable practices of tomorrow. As we wrap up our journey into the world of biodegradable electronics, let's take a moment to reflect on the transformative potential these innovations hold for our cities and our planet. We've explored how these eco-friendly technologies are poised to change the landscape of urban living, offering sustainable solutions that not only enhance city functionality, but also safeguard our environment for future generations. The integration of biodegradable electronics into smart cities marks an important milestone in our quest for sustainability. By harnessing these innovations, cities around the world can significantly reduce electronic waste, lower carbon emissions, and embrace a more circular economy. We've seen how biodegradable sensors can revolutionize everything from public transport systems to waste management, providing insightful data while naturally dissolving after use. These advancements are not just technological feats, they represent a shift in how we think about our relationship with the environment and our responsibilities within it. This journey has highlighted the importance of education and awareness in driving the adoption of these technologies. As more people and industries become informed about the benefits and applications of biodegradable electronics, we move closer to a world where sustainable practices are the norm rather than the exception. This informed engagement empowers communities to make choices that favor long-term ecological health over short-term convenience. In the words of visionary environmentalist Paul Hawken, sustainability is not about the survival of the planet. It's about the prosperity of future generations. This quote encapsulates the essence of our exploration. Sustainable innovation is crucial not only for the present but for paving the way to a thriving future. It invites us to consider our own roles in this global endeavor. How can each of us contribute to the advancement of these groundbreaking technologies? Whether through supporting policies, adopting eco-friendly practices, or simply staying informed and curious, every action counts. We encourage you to think about how you can be part of this exciting journey towards sustainable urban living. Share your ideas and thoughts on the potential of biodegradable electronics, and let us know how you envision them transforming the cities of tomorrow. If you found today's exploration insightful, don't forget to subscribe to our channel for more deep dives into futuristic technologies and innovative solutions shaping our world. As we conclude, let's circle back to where we began, the idea of a future where technology and nature coexist in harmony. As we've discovered, this isn't just a dream, it's a tangible possibility. By embracing the potential of biodegradable electronics, we take a pivotal step toward making this vision a reality. Together, we can build smarter, greener cities that are not just intelligent, but also compassionate towards the planet we call home. Thank you for joining us on this journey. We look forward to exploring more groundbreaking innovations with you soon.